Hi everyone, welcome to the Unit 1.2 review video. Okay, so let's start on the section that will not have your graphing calculator on. In problem 1, they're asking us to classify and determine the number of solutions for each system of equations. So I can go ahead and take 4x minus 5y equals 0. And in these problems, I don't necessarily want to solve. I want to get them in y-intercept form or slope-intercept form in order to see what their slopes and intercepts are. So I'm going to get solve for y. So I subtract 4x, and I get negative 5y equals negative 4x, and then I divide by negative 5. So my first equation is equivalent to 4 over 5x. Okay, my second equation, I can solve for y by subtracting 8x from both sides first. And I end up with negative 10y equals negative 8x plus 15. Then you divide everything by negative 10. And you end up with y equals 4 over 5x minus 5 over 3. I'm sorry, minus 3 over 2. Okay, so if you notice, the slope of this line is 4 over 5, and the slope of this line is 4 over 5. Now, the y-intercepts here is negative 3 halves, and this one doesn't even have an intercept. So we are dealing with lines that have the same slope, but different intercepts, which means that they are parallel, right? So they will never intersect. So the answers to number 1 is inconsistent and it has with no solution. Alrighty, moving on to number 2. The first equation's already in slope-intercept form, so now let's move the second equation to be in slope-intercept form. I've got to move the 2x over to the other side, so it becomes negative 2x. And then I have to divide everything by negative 1, so I end up with y equals positive 2x minus 7. Okay, well, you notice that, again, the y-intercepts are negative 7 and positive 7. So they have different y-intercepts and different slopes. Well, automatically, if they have different slopes, you can go ahead and assume that they will intersect, and that means that they're consistent and independent with one solution. All right, now moving on to number 3, let's move this first equation to y-intercept form. We've got to move the x over to the other side, so we end up with negative 3y equals negative x plus 1. Then we divide everything by negative 3, and we end up with y equals 1/3 x minus 1/3. All right, and in this second equation, we need to move the 2x over. So we have negative 6y equals negative 2x plus 2. Then we divide everything by negative 6. Okay, so you end up with y equals 1/3 x minus 1/3. All right, well, you notice that they have the same slope, so we know that they're consistent. Or I'm sorry, same slope. And we know that they have the same intercept. So we know that they are the same line. Okay, and if they're the same line, that means that they're always intersecting. So they do have a solution. In fact, it's dependent because they are always intersecting. They have infinitely many solutions. All right, so now let's move on to the next type of problem that will be seen on your test, which is graphing the equations. So once again, I like to get this in slope-intercept form, but if you choose to graph by your intercepts, that's fine also. So I'm going to change this to be y equals negative x minus 5. And I'm going to change this one. I need to move the positive 2 over, so it's negative 2y equals negative x minus 2. And then I can divide both sides by 2, so I get y equals 1/2 x plus 1. Alright, so the two equations that I'm going to be graphing are y equals negative x minus 5 and y equals 1/2 x plus 1. So I know my y-intercept for the first line is negative 5. So I plot that point, and then I use my slope, which we know is negative 1, and that means I'm going to go over 1 and down 1. So it's going to be decreasing to the right by 1 unit each time you move to the right. Okay, so there's the first equation. And then the second equation has a y-intercept of 1 and a slope of 1/2. So I'm going to go over 1, down 2. Oh, I'm sorry. I'm going to rise 1, go over 2. I apologize. Rise 1, run 2. And then you're going to go ahead and connect those points with your straight edge. Hopefully your lines will be a little bit straighter than mine on test day. And if you notice, where the lines intersect is your solution. So my solution to this problem is negative 4, negative 1. Right at that point right there. Okay, let's move on to problem number 5. X equals 8 is going to be a vertical line because every point on that line has to have an x value of 8. So if I just wanted to have a couple points with an x value of 8 and then draw that line. Okay, and then the next equation is already in slope-intercept form. So I'm going to go, my y-intercept's at negative 5. So I'm going to plot my point at negative 5. And then I'm going to rise 1, run 2 from that y-intercept point. And then if you notice, the lines intersect at 8, negative 1. Right at that point right there. So my solution is 8, negative 1. Okay, so those hopefully will be easy enough. You just graph the equations of the line and find the intersection point. All right, moving on to solving each system of equations algebraically. We can go ahead on number 6. I'm going to go ahead and use the process of elimination because I notice if I multiply my top equation by 4, I end up getting negative 20x, or sorry, positive 20x. Sorry, let's multiply it by negative 4. We're going to try that again. So I get negative 20x plus 4y equals negative 12 when I multiply that top equation. And then I'm going to keep my bottom equation the same. And what happens here is you get the x's eliminate. That was the whole goal. And then you end up with 0, another 0 pair with the y's, equals negative 24. Well, this is a false statement. So the solution is the null set. There is no solution to this problem. Okay? All right, so number 7, we have x and y in our denominators of both equations. So what we're going to focus on is our numerators, and I'm going to use elimination again. And looking at my x's, the numerators over my x's, I have 4 and 2. So I can multiply this bottom equation by negative 2, and I can end up with negative 4x minus 12 over y equals 6. And then I can bring down my top equation of 4x plus 5y equals 8. Okay, what happens here is these x's get eliminated, and you end up with negative 7 over y equals 14. Okay, so now that tells me my y value is equal to negative 1/2. So then I can take my negative 1/2 value and plug it back into one of my equations. And when I do that, I end up with, I'm going to use the original bottom equation. So 2 over x plus 6 divided by negative 1/2 is the same thing as multiplying 6 by negative 2. Dividing by a fraction is the same thing as multiplying by the reciprocal. So 6 divided by negative 1/2 is actually negative 12. And then that equals negative 3. So now when I go ahead and move that 12 over, add 12 to both sides, I end up with 2 over x equals positive 9. Then you can end up cross multiplying and you get x equals 2 over 9 as your solution. So my ordered pair, my solution to this system of equations, my x value is 2 over 9 and my y value is negative 1/2. All right, moving on to problem number 8. We're going to go ahead and use elimination here because if you notice, I have a negative 4/3 y and a positive 4/3 y, so that just eliminates. So when you bring down 3x, and then that's going to be equal to 7/3 minus 7/3, so that's going to be 0. So then you divide both sides by 3, and you get x equals 0. So now we just plug it back into one of our equations. So I can go ahead and plug back into the top equation. 2 times x would be 2 times 0. So it's really 0 equals negative 4 over 3y plus 7/3. Well, then what happens is I can bring that 4/3 y over to the other side, and it becomes positive 4/3 y equals 7 over 3. And then I need to divide by 4/3, which again is the same thing as multiplying by the reciprocal, 3 over 4. So y ends up equaling 7 over 4. So my solution is 0, 7 over 4. Alrighty, let's move on to the last two problems, 9 and 10, where we're solving algebraically. Okay, so I'm going to take my top two equations right now, and if you notice, the z's are positive and negative, so I know that that's going to be eliminated. So I'm going to take 2x plus 3y minus z equals 5, and then x plus y plus z equals 9, and the z's cancel, and that ends up giving me 3x plus 4y equals 14. Okay, so that's the first equation that I can use to go ahead and have eliminated a variable of z. Now I can take my second and third equation, x plus y plus z equals 9, and x minus 2y minus z equals negative 7. And notice that the z's eliminate again, and I end up with another equation with x and y in it, which gives me 2x minus y equals 2. So now I have two equations with two variables in it, so I can set those equal to each other. 3x, or set up a system with those. 3x plus 4y equals 14, and 2x minus y equals 2. Okay, then I need to eliminate the y's. You could eliminate the x's, but the y's seem to be easier if you multiply by 4. So you end up with, when you do that, 3x plus 4y equals 14, and 8x minus 4y equals 8. Okay, so now when that happens, the y's cancel. You end up with 11x equals 22. And then you divide by 11. So x equals 2 in this system of equations so far. Okay, so now I can go and plug that back into one of my top equations. So, or one of the two equations with x and y in it. So I can plug it in to 3. Instead of x, I can multiply by 2 plus 4y equals 14. So that's 6 plus 4y equals 14. Subtract 6 from both sides, and you end up with 4y equals 8. So y, in this case, also equals 2 when you divide both sides by 4. So now we know what y is, we know what x is. So we can go back up and plug into our original equations and solve for z. So let's go ahead and use the middle one. It seems to be the easiest. X plus y plus z equals 9. So I'm going to plug in 2 for x and y, and I get 4 plus z equals 9. So z equals 5. So the key there was taking two equations, eliminating a variable, and then taking one of those equations in the third equation that you didn't use the first time and eliminating the same variable to give you two equations with two variables, so you set up a two-variable system of equations. Okay, and then you just continue to find values and plug them in to solve. Okay, on this last one, we can use elimination by multiplying. I'm going to rewrite it over here for some more room. Multiplying the top equation by -5 in order to get our x's to eliminate. So let's multiply this top one by -5, and you end up with -20x plus 25y equals 15. Okay, so let's go ahead and rewrite our second equation to where the equal signs line up. So I'm going to bring this 25y over to the other side. So I end up with positive 20x, and then now positive 25y plus, or sorry, equals 15. So now, oh, I'm sorry, when I multiplied the top equation by -5, that should have become -25 there, and this should have become -15. Okay, so what happens is you get 3 zero pairs. So 0 equals 0, which is a true statement. And when you get down to that, that means that any ordered pair, so we can write it as x, y, any ordered pair will be a solution to this equation as long as it falls on one of these lines. Equals xy such that 4x plus 5y equals 3. Essentially, these two lines in problem number 10 are the exact same line. They're coinciding lines that will be graphed on top of each other that makes them always intersecting. Now, some of y'all will be tempted to put all real numbers, and that is wrong, because all real numbers is not the solution to the system of equations. The solutions are all the points that lie on that line, or these two lines, which happen to be the same thing. Okay, so let's move on to the next part, and we'll finish up this review. Now, the next part is without your calculator, so be prepared to put your calculator away at this point in your test. Okay, so this is the part of your test that you will be able to use a graphing calculator on. And the directions are to express each problem as a system of equations, solve the system, and state the answer to the problem, including units of measurement. Okay, so problem 11 says a locksmith charges $25 to make a house call and $15 for each lock that's rekeyed. Another locksmith charges $10 to make a house call and $20 for each lock that is rekeyed. For how many locks will the total cost be the same? Okay, so for the first locksmith, we're going to write the equation y equals 25 for the fee plus $15 per lock. So I'm going to put an x. 15. So y equals 25 plus 15x. For the other locksmith, we can write the equation y equals the $10 fee plus 20 times x for the $20 for each lock that's rekeyed. Now you can go into your calculator and you can go into a calculator page, hit menu, algebra, solve systems of equations. There's two equations that we're dealing with, and the variables are x and y. So we're going to hit OK. The first equation was y equals 25 plus 15x. And the second equation was 10 plus, don't forget the y equals. 10 plus 20x. Alright, and then you hit enter, and the solution for x, which is the number of keys, remember x represents the number of keys rekeyed, and Y is the cost. So the number of keys rekeyed is 3 locks is the appropriate answer for the cost to be the same. All right, now we're going to go for 12. Problem 12, it says a student-written performance is playing at a local high school. Rochelle paid $52 for 2 adult tickets, 2 student tickets, and 1 child ticket. So we can write an equation for 2 adult tickets plus 2 student tickets plus a child's ticket, and the total she paid was $52. RJ paid $56 for 1 adult ticket, 2 student tickets, and 3 children tickets, and that was $56. And then Ann paid $44 for 1 adult ticket and 4 child tickets. So those are the 3 equations, and now we can go into our calculator and do the same process. We go menu, algebra, solve systems of linear equations. This time we have 3 variables, and we can write them as A, S, and C. And then we hit OK. And then we type in our equations 2A plus 2S plus C equals 52. And then the second and third equation you can type in, and then you hit enter. And there are your solutions. A is 12, S is 10, and 8 is for the children's ticket. So those represent the cost of each type of ticket. So adult tickets cost $12, student tickets cost $10, and child tickets cost $8. Alrighty, moving on to number 13. It says a popular mixture of potpourri includes pine needles and lavender. If pine needles cost $1.25 per ounce and lavender costs $3.75 per ounce, how much of each ingredient should be mixed to make 100 ounces of potpourri that costs $3 per ounce? Okay, so each ingredient, so potpourri plus lavender, we want to make 100 ounces of that. So now we need to figure out the cost. So we have $1.25 per ounce of potpourri plus $3.75 per ounce of lavender. And now this time it's $3 per ounce, okay? So we're wanting to make, remember, 100 ounces of it. So we have to set the cost equal to $300. So that's what they're wanting to know, how much of each ingredient for it to cost $300. All right, so now we go to our calculator again and enter into our computer. We go our calculator menu, algebra, solve systems of equations. There are 2 equations here, and our variables are P and L. And that tells us how much of each those represent how much of each potpourri of pine needles and lavender we're going to need, how many ounces of each. Okay, so we've entered in our 2 equations, and once we hit enter, we get the solution of 30 and 70. So our answers are 30 ounces of pine needles and 70 ounces of lavender. So we can go ahead and fill that in. Alrighty, the last word problem we have 2 more, sorry. 14 says Karen earns $5,000 working part-time as a cashier in a department store. She puts her earnings into 3 different bank accounts. She puts some money in a checking account, which pays 5% annual interest, some into a savings account, which pays 6% interest, and the rest in a 1-year certificate of deposit paying 7% interest. No additional money was deposited or withdrawn from the accounts during the year. And the total interest at the end of the year was an average return of 6.5%. Okay, so let's start off. She has 3 accounts. So I'm going to name them X, Y, and Z. And those represent the amount of money that she puts in each account. And the total amount that she invests in those accounts is $5,000. Okay, the 3 different accounts give different interest. On the first account, the checking account, she gets a 5% interest. So we write that as a decimal as 0.05. times the amount she invests. So that's going to give us the amount of interest she earns on that specific account, plus the 6% interest she earns on the savings account, plus the 7% interest that she earns on the 1-year certificate of deposit account. And she wants her total percentage to be the total interest to be 6.5% return on her investment. So we need to go to our calculator, and we're going to multiply 5,000 times 0.65. So that's going to tell me the interest that she wants to get, and that is $325. Okay, and then the last statement that we need to read is that if she invests 3 times as much as 6% as at 5%, find the amount that she invests at each rate. Okay, so the amount that she invests at 6% is Y. And that is 3 times the amount that she invests at 5%, which is X. So I'm going to do 3 times X. Okay, and then once again, we can go into our calculator, hit menu, algebra, solve systems of equations. There's 3 equations this time. Okay, and 3 variables, X, Y, and Z. We hit OK, and you go ahead and type them in. And then you hit enter, and your answers right there are $500, $1,500, and $3,000. So at 5% interest, the amount that she puts in is $500. And then at 6%, she puts $1,500, and at 7%, she puts in $3,000. Okay, our last problem. Matthew has 74 coins consisting of nickels, dimes, and quarters. So we can write an equation from that first sentence as nickels plus the amount of quarters plus the amount of dimes equals 74. The total value of the coins is $8.85. So a nickel's worth 5 cents. That's the amount he has in nickels. A quarter's worth 25 cents. So adding the amount that he has in quarters plus the 10 cents per dime has to total $8.85. And it says if the number of nickels and quarters is 4 more than the number of dimes, find out how many quarters Matthew has. Okay, so the nickels plus the quarters has to equal the dimes plus 4, because there's 4 more of the combined total of nickels and quarters than dimes. Alrighty, let's go to our calculator again. Menu, algebra, solve systems of linear equations. 3 variables, and this time we're using N, Q, and D for nickels, quarters, and dimes. Remember, we're separating them by a comma. You hit OK. And then we go ahead and type in our equation. Okay, and then we hit enter, and you realize that he has 22 nickels, 17 quarters, and 35 dimes. And the question is asking how many quarters he has, so it's 17 quarters. Alright, y'all, so that ends our review video. I hope y'all, it's helped, and good luck tomorrow on your test. We will see you then.